All right, welcome everyone to this video. So what I'm going to be doing with this video is I'm going to be looking at the primitive types from the AP curriculum part 1, right? So we're just going to take a look at what primitive types are and how those primitive types affect the AP curriculum. All right, so this unit of the AP curriculum was designed to introduce Java to you as a programming language and introduce the use of data structures, otherwise known as variables. It's going to be, as data structures and variables are, a foundational concept, a real axiom, a starting point for all future units built on that. Now, the good news is, if you've been a computer science student of mine, you have already studied all of this material, everything about variables in both the computer science 20S course, when they had a whole unit on variables, and the computer science 30S course, which also dealt with variables at the start. Okay, so it's going to be talking about the main method as just methods in general, and how to produce basic outputs. It's going to be talking about how to create variables, how it stores value, and how you can use variables to perform basic operations like math operations. And this is going to be something you could build on in lots of future units. Okay, this is a snapshot right from the AP curriculum: why programming, why Java, variables and data types, expressions and assignment statements, compound assignments, assignment operators, casting and range of variables. All right. In terms of weighting on the AP exam, the curriculum states that for this unit, Unit 1 primitive types, it's 2.5 to 5% of the exam weighting. So that means it will be in about 2.5 to 5% of the questions or in the responses, the multiple choice or the response questions. All right, so let's start with topic 1.1, why programming, why Java? Here again is a snapshot of it from the AP curriculum, okay? So it describes this as using the code system.out.println and system.out.print to generate output to the console, which is essentially the computer monitor. And perhaps a term you're not familiar with, a string literal is basically words enclosed in quotation marks. We covered this content not only in the 20S course, but specifically system.out.println as it is Java-based, in the 30S course, Unit 1, Intro to Java. Let's take a look at that from that unit. So here you can see the traditional Hello World program, giving the basics of any sort of basic computer program. It shows one quick comment and the system.out.println command being used there. Comments in Java are often shaded differently by the IDE. For example, in NetBeans, they'll shade a grayish color. Comments are not considered code. You also will see other lines of code, for example, the Java class signature line and the package declaration line. Okay. The class line defines the class. Every Java file will have at least one class definition defined by you. These are user-defined classes. The keyword public is basically a version of encapsulation that we'll cover in later content. And there's some color coding done by most IDEs, including NetBeans and Visual Studio, to help you identify specific keywords and their effect on the program itself. Okay? Class names, by definition, generally follow the style where they start with a capital letter and then go to camel casing if necessary to avoid spaces and other types of characters such as dollar signs or underscores. So generally a class name is a combination of letters and numbers, must start with a letter, and it will start with a capital letter and then use camel casing if necessary. Hey, curly brackets are going to be part of coding in Java. Curly brackets define blocks of code, and they're used by various things, including both classes and methods and control structures like conditional statements and loops. Brackets are essentially fundamental pieces to hold the programming code together. It is a good programming practice to put the brackets into a style that you're comfortable with, whether that's putting them each on their own line, which is more of a Visual Studio C# style, or perhaps putting them on the same line as code, as long as you have a consistent style that makes reading the code more consistent for other people reading your code. Okay, now the key line, system.out.println, instructs the computer to go to the system. This will be the default output device. In most cases, that will be your screen. Out obviously implies that it's performing an output, And although print line implies that we're sending it to a printer, what we're actually doing is calling a method to send the literal, which is the words inside of quotes, through print line to the output of the system. In simpler terms, when this line executes, the words hello world will appear on the screen. Okay? Now, as inputs and outputs get fancier, as it did in the grade 10 computer science course, you eventually can build up to fancy things like graphical user interfaces. But the system.out.println method provides the most basic of outputs to get some of the basic functionality of computer science in place. Okay? So as I mentioned before, system and println actually tap into deeper concepts like classes and methods that can be covered further on. Round brackets, curly brackets, semicolons, all those little symbols have meaning, but again, at this point, just as long as you have a general idea of the difference between system.out.print and system.out.println, you'll get a general idea by what this first essential curriculum piece is about. The difference is that println or println will put out your literal and then a line break, whereas print without the ln displays your literal without a line break at the end. Okay? We can also use special escape characters like /n, /t, // and /quote to insert those special characters into the string literal. So for example, right in the middle of the string literal, if I put /n, it won't show a /n on the screen. Instead, it'll insert a line break into the default output. If I put /quote, it'll put a quote into the output rather than, so when that's in the literal, it knows to use the escape sequence to provide the output in that format. You can also see this if you look back in our examples. For example, the 30S example, you can see a screenshot of it here, has got that code in there, and it explains the difference between println and println. Print and println. All right, moving on to topic 1.2, variables and data types. Let's move on. The curriculum describes this as identifying the appropriate data type for a particular specification and declaring variables of the correct type to represent primitive data types. This was again covered both in the 20S and specifically in Java in the 30S. Let's dive into this content. So variables represent data in your program. It's defined as a named memory location that can store or hold on to a value. Variables can be thought symbolically as mailboxes, where you can put data inside and then find it based on its address. You can change what's stored inside, but whenever you change it, whatever was previous in there is removed, and the original item is now stored. You can refer to variables by their identifier name, otherwise known as their address. To create or declare a variable, you need to do two things. One, you give it a name, an identifier name, and two, you give it a data type. The type refers to what type of data you're going to be using to store, whether that's numerical or textual or logical or otherwise. A variable can only hold one data type. Okay, so it's in the definition where you define the type. It stores a value, you give it its type, you potentially give it its value. Most data types that are built into the Java core programming language don't have to be defined, but then as a programmer, you can later, as you get more complicated, define your own custom types of data. All right, to create a variable, you make a declaration statement. Built into Java, okay, are a number of primitive or built-in, or even sometimes called atomic data types. There are 8 built-in atomic data types in Java: the byte, the short, the int, the long, the float, the double, the char, and the Boolean. You will not need to know all 8 types, as some of them, especially the numeric types, are basically just variations on there. There are more types even beyond that 8 that just get a little more specific, but those 8 types generally can also be narrowed down. So for example, byte, short, and int, really you just need int. Long and float and double, okay, again, float and double, really just int and double usually cover most of your basic numeric types. Char stores a character, Boolean stores a true false value, as we'll see further on in this presentation. You give the type, you give your identifier name, and then you should, although it's not necessary, initialize your variable to a starting value. Here is an example of an integer with its identifier type number and its initial starting value at 0. So here's the byte type. It is a whole number with no decimal value stored. It can store any number between the negative 128 all the way up to positive 127, including the 0 value. Okay? Here's an example of it in being declared, byte number equals 100. Moving on to the next type, the short has a slightly larger range. Now it goes from negative 32,768 to positive 32,767. Remember, 0 technically counts as a positive number. That's why there's one more on the negative side. The short uses 16 bits of data to store this value. The integer has a larger range. Now we're talking in the billions, but it uses more memory. It now uses double the amount, 32 bits of data to store each variable of type integer that's stored. The long is an even larger capacity. Now we're talking beyond the trillions, and this now uses, again, double the value at 64 bits to store. Obviously, these are all whole numbers. They don't store decimal values. The float is the first type that can store a decimal value. It requires 32 bits of storage. And the double, which is the most precise, is the largest and most real representation of data that involves both a whole number portion and a decimal portion. The char, also just a shortened version of the word character, holds one character. Okay, that character could be a letter, okay, or it could be a number, or it could be a symbol. That character value comes from the ASCII table of characters, the American Symbolic Code for Information Interchange. When you create a char, you declare it and you assign it a value using single quotes or apostrophes to assign it its starting value. And finally, the Boolean type, which in Java uses the entire word Boolean, unlike C# and languages like C++, which use the shortened version bool, stores either true or false values. So the Boolean is the simplest, uses the least amount of memory. Java is a strongly typed language, as is C#, which means our syntax and our upper and lowercase lettering matters. So a capital letter will be interpreted differently than a lowercase letter. Okay? Strongly typed languages means as a programmer, you need to be more engaged in your coding. This actually leads to fewer bugs and fewer compiler errors, and obviously faster code when compiled, but it doesn't allow for as much flexibility for you as a programmer. So when you create your variable, it must begin with a letter. So for example, your variable could be called A1, but your variable could not be named 1A. It has to start with a letter. It cannot have any punctuation or spaces, which means you can use camel casing style again to help potentially make it look like a space is in place. Okay? You can use letters, numbers. Dollar scores and underscores are also allowed, but not recommended. There are special sort of circumstances for those. Case matters, upper versus lower case. And the good style you would generally use is that camel casing style. So these are some examples of legal variable names in Java, and these are some examples of illegal variable names in Java for various reasons, using illegal characters, spaces, etc. The other illegal characters for variable names are keywords. So you couldn't, for example, name a variable int. You couldn't say int and name it that, because int is already a reserved keyword in Java. We covered all this in the curricular content of 30S, and you can see more in the big example we did back in that. Moving on to topic 1.3, expressions and assignment statements. This is how the curriculum describes that. To evaluate arithmetic expressions in code, to evaluate what's stored in a variable as a result of that. And this was again covered. Once a variable is created, you can change it. However, in Java, unlike math, the thing assigning to always goes on the left-hand side, and the value being assigned always goes on the right-hand side. It's not reversible. Math operators are used like multiplication, division, addition, and subtraction. You can also use sometimes the addition side to concatenate two string literals. That doesn't mean to add them, it just means to join them together. Okay, there is a precedence value as there is in math. So multiplication and division is always done before addition and subtraction, and that can be overridden with brackets. For example, as you see in this equation, the brackets are overriding the precedence order of the mathematics. If everything's of the same precedence, then a evaluation goes from left to right. This is the kind of question that can often throw students off. As the AP might throw you a evaluation type question, you need to remember your precedence rules and the left to right rule as well. Okay. Now Java, of course, also has other things like the modulus division symbol or the unary, or the essentially making a variable negative sort of thing. Okay, integers are evaluated differently than doubles in things like division type things. And now let's move on to constants. Constants are variables that don't change. In Java, the keyword final is used to declare a variable as a constant, and the style of naming the variable changes to an all uppercase style with underscores being used to separate words, as we can no longer use camel casing. So a good example, the simplest one would be the value pi. Pi could be created as a final or a constant, or even strings or booleans or integers can also be used to create constant values. Okay. Constants makes for easier to read code. It ultimately does make for faster code when you have constants, because they tend to process faster with a constant. They're easier to update. They make, as I said, more readable. And so constants are a very good thing to apply to your programming. All right. Adjusting the camera here for this video. Okay. So that was also in our example. So now we're going to go on to 1.4 compound assignment operators. The AP describes this part of the curriculum as evaluate what's stored in a variable as the result of an expression with an assignment statement. So this really is just basically things like getting used to how variables are manipulated. Things in shorthand that you've already covered, like the plus plus operator and the minus minus operator, to increment, add one, or decrement, subtract one from a variable value. You can also move to more complicated things like the plus equals, minus equals, multiply equals, and they're equivalent in how they would be evaluated that way. Okay? And you can see examples of this through the semesters, through the coursework you've done. You should be able to look back on this in examples in curricular content. Moving on to 1.5, casting. The casting of values is described as expressions that use casting. So the simple answer for casting is converting one data type to another. Most specifically, this is done with numeric types. Okay? So this is now when you're working with two types, a double, say, and an integer. Will the result of doing arithmetic with that result in a double or result in an integer? It could be undetermined. So sometimes you want to convert one to another. Cast a double into an integer. This will remove the decimal portion by truncating it, by removing it. It won't round it off. It'll just remove the decimal portion. Similarly, you can cast an integer into a double. It just adds it so that it can now be calculated into double type values. So there's all kinds of casting you can take place, not just between integer and double, but between multiple data types, including even the character type can be cast, or the Boolean type can be cast. Sometimes your casting can't be done, sometimes it can be done, depends on sort of what you're casting and into what. But we've done lots of examples of this through the 30S course. If you look back, links provided to find this. If you're having struggles sort of processing what they mean by casting, you can find it there. All right, let's summarize this video and summarize this AP unit. So let's take a look at what the unit said. The unit said, sorry, let's go back to this view right here. Having studied this with all the computer science coursework, having already completed all this in various computer science courses with me, let's review this and take a look at a sample type AP question that could come up from this curricular content. So this goes from 1.1 to 1.5, as we just stated. Here you can see them all checked off. Why programming? Why Java? Variables and data types, expressions and assignment statements, compound assignment operators, casting and ranges of variables. Be comfortable with the language, be comfortable with what the AP could ask you. Here's an example of a question that could potentially fit into this curricular content. So here you see, consider the following code segment, and then the multiple choice options A through E, okay? So 3 variables hold values, but the first 2 are different types, okay? Than the last one. So you have an integer, and then a double, okay? So the output line follows an order of operations, which means multiplication and division is always going to be done before addition and subtraction. And if they're of the same precedence order, it's going to go left to right. So if you look at that, the A divided by B is going to be done first. Then it's going to multiply it by C. So we're going to go 5 divided by 2 multiplied by 3.0. So we're going to get the answer 6.0. Then the addition and subtraction is going to kick in. And it's going to go left to right. So it's going to go 5 plus 6, which is 11, minus 1, which is 10. Okay? So you can see that eventually get evaluated. Okay? And it's going to then take 5 divided by 2 as the sort of potential thing there. And 2.5 is going to get truncated to 2. All right, we've already covered that. Then go left to right. So the final answer is going to be 10, as I mentioned. 10.0 is going to be the answer because it's going to spit it out as a calculated value in the end. All right, here's another type of question. In this one, we have the variable A, but we have an order of operations event occurring again. So the multiplication is going to be done before the addition. So 2 times 3 is going to give you 6 before it's added to 3. So A is going to be 9. Same is going to happen with B, and it's going to evaluate to 5. Then when it gets to C, it's going to do a modulus division, okay? So it's going to pull the remainder of 7 divided by 4, which is going to be 3. Add that to 3 to give you 6. So then D is going to be A plus B plus C, which is 9 plus 5 plus 6. And because it's a double, it's going to evaluate to 20.0 as the final answer. So here you can see in these 2 questions, it's using the variables and it's using order of operation and kind of trick questions there to get through that. Now, as we wrap up here in the presentation, I also want to show you guys this from the AP content perspective. Okay, so here you can see this here. Okay, so here you can see just some of this review, examples of comments in there, examples of simple outputs, examples of dialogue outputs as well. So this is from our study. Here you can see the basics of using a variable. Okay, this is a piece of memory that stores information created with code, and that it is part of the computer's memory. How you code a variable, some different versions of that, how it's assigning it a value, and how that code breaks down. Here you can see what types of variables there are. Type meaning what the variable is storing, from numbers to text to true false values. Here you can see how you use variables, how you can assign it, reassign it, use a formula, don't forget your order of operations, and even converting it, parsing it, and casting it from one type to the other. Here you can see a constant in use, right? A constant, a variable that does not change, how it's locked and how it's in place there with that. And the difference between a local and a global variable. This, again, is starting to spill into stuff that you'll see in other parts of the AP curriculum there, but still dealing with variables and how that works. Okay, so there's a quick summary of variables in general, sort of all the sort of things I just covered there on variables and how that all kind of fits together. Here is the AP content, all laid out here the learning objectives, and the vocabulary along the side. And that'll conclude today's video. Feel free, as my AP students, to continue to add to the shared documents, the curriculum document, the practice questions, and our shared coded example. Be sure to like and follow. Have a great day.